Hey guys, in this video we're going to talk about how to find, not necessarily how actually, but what are the attributes of what makes a quadratic function special. In the next video we'll talk about how do you find the attributes. For now, I just want to show you what these vocabulary words mean here on your screen. Right? We're going to be talking about how to find what the vertex is, the axis of symmetry, the general function of a quadratic in vertex form, x-intercepts, zeros, and roots, the focus on the directrix, maximum and minimum. So this whole video is specifically geared to the vocabulary words we're going to be using in this unit and being comfortable with what they look like, how they behave, how are they a part of what we're dealing with. And again, in the next video, we'll talk about how do you actually find them. So let's get started. The vertex and the axis of symmetry. So the reason why I put these two together is because the parabolas actually, these two go hand in hand. When you have a, if I draw a parabola, this could be pointing up or pointing down, it doesn't really change. The vertex will always be that center point of the parabola. So that's going to be down here. This is the vertex of the parabola. Now usually these two, this point will be known as h and k, where h represents the x value and k represents the y value of that ordered pair. The axis of symmetry, or the AOS, is an imaginary axis or imaginary line that splits the parabola down the middle. It serves like as a mirror of the function in itself. So the axis of symmetry will always go through the vertex, and because it's vertical in this scenario, it will be written as the equation x equals some number. And that number is really going to be h, just because we know it's going to be touching that value, right? It's going to go through the vertex, so x is going to always equal that h value that we're looking for. Maximum and minimum. So let's talk about what that looks like, okay? If the parabola is pointing upward, then this lowest point of the graph, the vertex, is considered a minimum. It's considered a minimum because it's the smallest, most minimum value that the function will ever be. If the function is pointing upside down, now the vertex is considered a maximum. Because that is the maximum value that the function is ever going to be. From a function, we can actually tell whether or not we're going to have a minimum or a maximum. Okay? If we look at the general function of a quadratic, and this is f of x equals a x minus h squared plus k. The vertex is this point right here that we established earlier, h and k. So that covers these two terms. How do we know whether or not that vertex will be a minimum or a maximum? Is really dependent on this other term, the letter a. If a is positive, we know that the function is pointing up. So when a is positive, we have ourselves a minimum. When a is negative, as in this scenario, when a is negative, we know that the parabola is upside down or reflected over the x-axis. So then I know that we have a maximum for the vertex. So you can really tell a lot from just a function alone. You can always graph this on Desmos and figure out what it looks like and see if it's a minimum or a maximum. But you can also tell whether or not this point, hk, will be a minimum and maximum from the sign of this value alone. Let's talk about x-intercepts. Now, there's many ways of describing an x-intercept. It's also known as zeros and roots, but it really comes down to just where does it cross the x-axis. If I have a parabola, let's do this. Sure, I'll do it here. If I have a parabola, wherever it touches or crosses the x-axis, we call that the x-intercept. So So in this case, there are two x-intercepts. Here and here. Now there's other possibilities, right? We could have a parabola, let's say in this other scenario, where there are 0 zeros or 0 roots because it doesn't touch or cross the x-axis. So this would tell you a scenario where it would have 0. And you could also even have a parabola where the vertex is right on the x-axis. I didn't touch it, but it's supposed to be touching it right there. If it touches it once, it could have one x-intercept or one root. And in this case, as I mentioned in the other ones, we can have up to 2. So you can have one x-intercept, 2 x-intercepts, or none. Lastly, let's talk about focus and directrix. This is the last attribute of what makes a parabola a parabola. Now, the focus and the directrix is actually what truly defines this function for what it is. I'm going to draw a parabola here. We still have the vertex centered there at the bottom of the graph. And we'll call this h and k. Now, the focus will always be found in the direction of where the parabola is pointing. So if the parabola is pointing up, we can find ourselves the vertex right above it, on the top part. Now, the focus will also always be on the axis of symmetry because it's perfectly above and right in the same direction as the axis of symmetry. So this point and this point, the focus and the vertex, are always lined up with each other, which means they're going to have the same x value. The only the value is going to change is the y value because it's going up in this case. Now, in the exact opposite direction, we also have the directrix. The directrix is a line that is equidistant from the vertex as the focus. So if the focus is 2 units above the vertex, we're going to go 2 units below to find the directrix. It's the exact opposite distance. As this one gets higher, right, if we go up to 10 units away from the vertex, then the directrix will always be 10 units below. Okay, now the directrix, because it's a line, we're going to write it as y equals some number. And the focus, because it's a point, we're going to write it as a point. Since it's the same x value, we're going to have to use h, and then some other y value. We'll leave this blank. We'll talk later in another video about how to find those numbers. Now, this is if the function or the parabola is pointing upward. Same thing if the function is upside down. If it's upside down, we have this scenario. The vertex is still, in this case, is a maximum. The axis of symmetry still goes through the vertex. And the focus, well, the focus will always be, I'll put this in, the focus will always be inside the parabola. So now in this case, the focus is going to be below. And it's still a point, right? So we're still using h and some number. Here we have h and k because it's the vertex. And now because the focus is below the graph or below the parabola, right? Let's say it's 2 units below, the directrix will be 2 units above. The directrix will always be on the exact opposite side of the focus. Okay? So, we covered a lot of words here, right? We covered maximums and minimums. We covered the vertex. We covered the equation. We covered x-intercepts, and then lastly here, focus and directrix. All of these words, you want to be able to know what we're talking about when we're dealing with them. In the next video, you'll learn how to find all of these attributes, but for now, we want to be able to just recognize them. Do you know what they look like? Do you know what we mean when we're talking about focus and directrix, maximums and minimums, vertex, x-intercepts, zeros, roots, all of those terms? This is going to be the foundation for the unit and the next unit as well, because the next unit we're going to be dealing with more parabolas, so we want to be able to describe and talk about it using these vocabulary words. Let me know if you guys need anything, and as always, I'll calculator.